Hi, what's up guys, it's Evan here. In today's video, I'll be teaching you how to solve the Square-1. So before we hop into this cube, you need to learn how to solve a normal 3x3 before learning this cube. And what the weird thing is about Square-1, it uses numbers as algorithms, and it shape shifts as well. So before I teach you how to solve this and we scramble it, I need to teach you guys notation first. So notation with a Square-1 is with numbers and slashes. So a slash move is basically when you're moving the right piece 180 degrees, something like this. I'm going to do it one more time. So a Square-1 slash is something like this. Slash, this is a slash. So you see it's on white. So it's like you're like moving the piece of the cube 180 degrees. Doesn't matter, it's mostly the right side though. So now, since you know what slashes are, now let's move on to notation. So you might see like notation, like for example, you might see a notation like 1, 2. That's kind of what notation is like. So the first number you see in like the numbers, it goes like 1, 2 slash. If you ever see something like that, the first number is with this top layer. And if you want to do a positive number, say like 1, 0, you can do 1. So you want to watch this piece on the right. That helps you with your algorithm. So 1, 0. I just moved this piece over 1. And now with the bottom, if you want to do it with the bottom and you want to do a positive number, you move it counterclockwise. It's clockwise with the top. So now if you ever see a 0, like 2, 0, I would move this piece over 2. And then 0 means you don't move the piece at all. That's what a 0 is. So now let's look at the bottom. So like let's say like 0, 2. Like on the bottom, you move it counterclockwise 2 times. 1, 2, and yes, and the corner counts as 1. So now let's try combining the two together, and then we'll include a slash in a second. So let's try like 3, 2. So I would move the top 3 times. 1, 2, 3, and then move the bottom 1, 2. So that's what it is. So now let's try with the slash this time. Let's try like 4, 3. So 1, 2, 3, 4. And then 1, 2, 3, and then slash. That's kind of what it would look like. So now, since you guys know positive numbers, now let's move on to negative numbers. So the negative numbers is kind of the opposite. So if you have a positive number going counterclockwise at the top, it's counterclockwise for negative. And then it's opposite with the bottom. So you move it clockwise for negative on the bottom and counterclockwise for positive on the bottom. So now let's try like a number like negative 2 on the top. So negative 1, negative 2. So I'd move it counterclockwise 2 times. Now let's try like negative 1 or negative 3. Let's try negative 1. So I move it like clockwise 1. Now let's try like negative 3 on the bottom. Negative 1, negative 2, negative 3. Now let's try including a slash in it. Let's try like negative 2, 3. Negative 1, negative 2, and then negative 2, negative 3. That's the algorithm. So I did negative 2 on the top. Now time for negative 3. Negative 1, 2, 3. And if you want to include the slash, like negative 2, 3 slash. 2, negative 3 slash. That's kind of what it would look like. So that is all for notation. Now I'm going to scramble up this cube, and we're going to get started. I also, like I said, do recommend learning the 3x3 before learning this cube, because this is a pretty challenging cube if you learn this. This is actually a pretty tough cube. I mean, it took me like a few days to learn how to solve it, like 3 days or something like that. I want to scramble this good so you guys can learn something from it. Alright, so I have the cube all scrambled up. So now so the first thing you want to do is look at your pairs. So like look at pieces of 2 you have. So like I have a piece of 2 right here, a piece of 2 here, and then I have a pair here, a piece here, and a piece here, and a piece of 2 here. I'll actually be right back. Alright guys, I am back. So like I said, you want to look for pairs of 2. So you want to connect them together and you'll have 8 pieces together. So I have like a pair of 2 here and a pair of 2 here. Let's see if you have any other pairs of 2. So I have a pair of 2 here. This is kind of like, you can kind of just learn this yourself. So you can try to move the pieces around and then eventually you will create pairs. So like I just moved a piece up and now I have a pair of 3 here, a pair of 2 here. So let's try to see if I can connect them together. And no, I can't. I have a pair of 3 here that I can move though. So just kind of mess with it around and then eventually you will get it. This is kind of like learning, kind of like learning it by yourself a little bit type of thing. So I have a pair of 2 here, piece here, a piece here. I have a pair of 3 here, so I'm going to just move the pieces around until I can find a angle to move it. And I did. So I have a pair of 2 here and a pair of 2 here. But the problem is, I need to get the pieces next to each other. Something like this. So now, since I have the pairs of 2 together, now I have a pair of 4. This is what you want, so now let's look at another piece here. Sorry I don't explain this well, but this is kind of like intuitive, so now let's look at a pair of 2 here. So I have a pair of 2 here and the pair of 4 here. So if I want to get it next to it, I'm going to move it closest to this, and now move this piece to the top, and you know that it doesn't work. But you can move it to the side though, so I'm just going to move it to the bottom, and now try it. Even though it does move one piece, if you have a case like this where you have a piece of 5 and then you have a piece here, you can just mess with it around and then see if you have a pair. And you might not. Now I have a case where I have 2 pieces across from each other. It's easy to insert, so now I can just put them together like this. And now you have 6 pieces. And now you have a pair of 2 here. And now you have your pieces solved. But there is another case you can run into, is having 2 pieces like next to each other. Like having one there and one there. What you do is replace one of your pairs. And then just kind of replace that line and put your pair back. And then you would put it in just something like this. But this isn't, if you want to see some other examples, please go check out some other tutorials on this cube, like a better example. So now if you have a cube shape, like something like this, now it's time to learn our first algorithm. So now you might run into a few cases with this cube where you're having this thing sticking in and or being flat. If you have this square thing in the middle flat, just do it where you see one of those lines. It does not matter. But if you have something like I have, you want to put this middle piece right here that's facing towards this inner part right here. And then once you have that, it is time to learn our first algorithm. To make this into a cube shape, the algorithm goes /(-2) -4 /(1) -2 /(3) And now you have it technically into a cube shape. You might have this thing sticking out, which is okay. So now let's see what cases you guys have. This is also kind of intuitive as well, where you have these pieces. If you haven't checked out my 2x2x3 tutorial, you can watch that and this will really help you. So now I have a case here, and if you want to keep the shape a cube and not avoid cases like this where you're just moving it and you lost the cube shape, just do a single 1 move on the top in between, and then you can turn it and it'll still remain a cube. So now once you have corner orientation done, now it's time for edge orientation. So you might end up with a lot of different cases. It's going to be hard to explain them all. And I always suggest when doing this step, have this little rectangle thing to the right and having this little square to the left. So now let's look at what case I have. If you have all 4 pieces mismatched, or 3 like this, or just 1, have one of them to the left. So have both these to the left if you have 3, and then 4 you don't have to worry at all. And now what you do next, if you have 1, make sure one of them is facing down and the other one's facing left. And now you want to do this algorithm to get this done. 1 0 /(-1 -1 /). And now you have the other case I was talking about. And now what else you want to do is look at what piece it is. So you have 1 here and then 1 here. So it's already in place. And now what you can do to fix this is now do that same algorithm I already taught you. 1 0 /(-1 -1 /). And now you have another case where you have 2 pieces on top of each other and one like this. So now, there's another algorithm you might run into when doing this, and the algorithm goes slash 30 slash -3 -3 slash and then 0 -3 slash. Now you have a case like this where you have two pieces like this and two pieces that you want to put like this. And now do the same algorithm again. Slash 30 slash -3 -3 slash 0 3 slash. And now you got the easiest case possible where you have two bars next to each other. And now just do this algorithm to fix it. 10 slash -1 -1 slash. And now you have all your edges solved. Now it's time for corner permutation. So let's start with the white side. It does not matter what side you solve with, but let's look. So let's see how many corners you have. You want to check and see if you have matching corners. So this is blue and orange. That's not match. This is green and blue, not a match. Orange, green, not a match. And this is red and red. That is a match. It's okay if you don't have a match, but if you do have one, make sure it's on the left. And now you want to do this algorithm. Slash 0 -3 slash 0 3 slash 0 -3 slash 0 3 slash. And now you have all your corners permutated on one side. Now you want to do the same thing on the other and check and see what you have. So now let's see what I have. I have blue, blue. That is one match. I have green and orange, and then orange and red, and this is red and green. So now let's put the one piece on the side, and now you want to repeat the same algorithm you did before. Slash 0 -3 slash 0 3 slash 0 -3 slash 0 3 slash. And now you have corners on the top. You might mess up the corners on the bottom, but just do the algorithm on the bottom. You might have this slash instead, but just repeat it like that. Slash, just do the algorithm again. And then eventually, once you have something like this and you have the sting sticking out, put it facing in front of you and put the corner to the side if you don't have any. Do the algorithm again. And eventually, you will have all of the corners solved. So now let's move on to probably, I think maybe to me, the hardest step on the Square-1, edge permutation. So let's see, what edge permutation is taking these two corners and having this edge getting replaced with another one with the corners and putting it into its solved position. This is what you want, and now if you have something like this where you have a solved piece, you might have none, you might have one of them, you might have two across from each other, two next to each other, or have all of them solved. In my case, I have one like this. So if you have one, make sure it's on the left. And like I said, with corner, I didn't say this before, with corner permutation, you want to do a 3 move in between your solves, or just put the corner on the left. That's kind of what I call it. But instead with edge permutation, you're just going to do a single 1 move, just like this. So you want to look at the right side, and now let's look at this edge piece. It is green. So is the green corner pieces in the front or the back? It's not in the back because that's blue. It's green, so it's in the front. So you do the same algorithm you did with corner permutation. You'll do the algorithm twice, and then you do the 1 move for the second time you do the algorithm. But if the piece needs to go to the back, what you can do is just do the 1 move first and then do the algorithm twice. So now let's do the algorithm twice. Slash -3 0 slash 0 3 slash 0 -3 slash 0 3 slash. And now since you've done the algorithm for the first time, you're gonna have this thing. You're gonna have to do that 1 move second and do the algorithm again. And then eventually, you will have your edges solved on this side. Now you want to look at the other side and see what you have. So let's look at this side. You might have to do it like this, but that's okay if you do. It's not a hard fix. So let's look at this piece. Does it need to go to the back? It needs to go to the back. Since I can't do the 1 move since the corner will be in the way, I'll just do a -1 move and try it. Or actually, just try to get it into a cube shape first. This might be an easier solution, and just check and see if you have the corner solved. Just do corner permutation, and then eventually you'll just do the same things over and over again. This is kind of a repeated process, but there's not really much for me to say in this. But if you have the case where you need to move the piece to the back, and then what you can do to fix that is actually just do the 1 move first, and then once the piece is sticking out, just move it back in. So if you have the case where you have something like this, you have all 4 pieces solved and none on the other, and you can't do anything, do the parity algorithm. So if you don't know what the parity algorithm is, it's a very long algorithm that helps you move this piece, like makes this piece stick out, which is really helpful for edge permutation. And now you just do this algorithm to do it. I'm sorry you have to memorize it. You just have to memorize this algorithm. The algorithm goes /-3 0 /0 3 /0 negative 3 /0 3 /2 0 /0 2 /negative 2 0 /4 0 /0 negative 2 /0 2 /negative 1 4 and then 0 3 negative 3 /. And now you will have that thing sticking out like normal, which will be really helpful for you for edge permutation. But if you do have a case where you're looking at the right and it can't go to either the front or the back, just do the same algorithm I taught you, and then just do the one move the second time you do the algorithm, and then eventually it'll be fixed. You might have a case where you do have two pieces on both sides solved. You just keep repeating the same steps. Just keep doing parity. Just kind of do all the stuff I taught you. So let's look at this side. I have one piece over here, and now let's look at this. So I want to put it on the left. Now let's look at this piece. It needs to go to the front. So I'm going to do the algorithm once. Do the one move second. Eventually, it will be solved. And now it's time for the final part. This is another parity case you can run into, is having all four sides solved on one side and having two on the other. So just repeat the parity algorithm after having both sides, like the two sides facing up. And now just do the parity algorithm one time. And then eventually you will have your cube solved, except for one tiny thing. So you couldn't see that, but you at least could hear my voice. So now, if you might have the cube solved, but you might have a case like this, where you do just need to swap the middle layer piece. There are two different cases. I'm going to show you one of them first. So one of them you can run into is having this middle layer piece swapped with the opposite side, like having one incorrect piece like this. Like this piece is switched. And like when you do... And what you do to fix this kind of case is do a slash, do a 6 move on the top and bottom, and then do a second slash, and now you'll get the easiest case where you have this solved, and it's swapped, and now you just do a slash, a 6 move, 6 or negative 6 move, slash, 6 or negative 6, slash, and then your square one is officially solved. Hopefully you guys enjoyed this tutorial. I had a hard time making this, so please leave a like down below for this. And subscribe as well for some more tutorials, and I'll catch you guys soon. Bye.